So say we're solving equations from word problems. Somebody point me in the right direction. What do we do here? Oscar. Put that together in a more clear statement for me, please.
Underline keywords.
So he's saying underlying keywords, okay? Somebody else. What do we do? I'm not saying you're wrong. Jacqueline. Okay. Anybody else? Something different? Isaiah.
What's the total amount?
That's where we start? There we go.
No.
Done, right?
No. 20 others.
Oh, okay. Something like that. What else? Any other ideas? Any other thoughts about what we need to do here? Sadie?
I lost 350 and 150.
Box 350 and 150. Okay. Ricardo?
You gotta square the wait, you gotta circle the each. Or square.
Okay, circling the each. Anybody, any other things they feel like we need to do, or we should have done, or otherwise they went about doing this? Michael?
I think we should, I don't know.
All right, anybody else? Genesis?
Circle the unknown G.
Circling the unknown G. So it sounds like a lot of you have gone through and you've done a lot of work here thinking about this word problem. And here's the interesting thing. I'm going to read through this problem, and what you're going to learn about me when we get to another unit that's a little bit heavier on word problems, so you're going to find this is the first thing that I'm going to do. I'm going to come straight for the question. And I'm going to read the question. It says, how many Gatorades G can Joshua buy for the girls? Now, I'm not going to make you do this unit yet. But the next thing that I would normally do is I would write a answer sentence to answer that question. How many Gatorades can Joshua buy for the girls? I would write, Joshua can buy blank Gatorades. Now, when I'm looking at this question, it says, how many Gatorades G can Joshua buy for the girls? If I just completely, lose my mind here, and I ignore all of that, can I answer this question? Why not? Andrea? Genesis?
Because you don't know how much, like the unknown, like G, you won't know how to get what G is.
So she's saying that if I ignore all these words up here, there's no way for me to know what G is. This is really common. The answer is, yeah, I can totally ignore all that information. Because what do I have? An equation with G in it. So all of that information up there in this particular problem is just extra information to tell us where the equation comes from. And it's going to be really important at some point in our algebra careers to be able to take a question like this and create this equation ourselves, but in 7th grade, we're only being asked to solve the equation. So what we really need to double check is the question and say, is this question asking me to solve for G? In this case, the answer is yes. It's saying how many Gatorades, and it's telling me Gatorades is G. So all we got to do is solve the equation. Now, does all of the hard work that you guys did thinking about where this equation came from hurt you? No, it doesn't, because later on we're going to get to units where you're going to be asked to write equations yourself. So if you're reading these questions and you're using that as an opportunity to practice and understand where these equations come from, you're doing yourself a favor. But the big picture is here. If we read this question, it's saying how many Gatorades G, and then it's giving us an equation that we can solve for G, we're good. We actually don't need to know the rest. If we're curious, $20 is the total amount, and that comes from 1 peanut butter, the $3.50, added to $1.50 times the number of Gatorades. That's where the equation comes from. We don't need to know that to solve this problem, because we're given the equation. So all we have to do here is solve the equation. What's the first thing that I need to do to solve this equation? Mr. Posey.
The first thing you have to do is, well, I was about to say this ain't switch, but you have to write an in with the
Additive
operation.
inverse, okay? So what am I going to add to both sides?
350, negative 350.
All right, 20 plus negative $3.50 is equal to $3.50
Why didn't you write it backwards?
plus negative $3.50 plus $1.50 times G. So this adds up to 0. Cancels out, leaving us with $1.50 times G over here. And this adds up to $16.50. Now we know the inverse operation here is to divide by $1.50. $1.50 divided by $1.50 is 1, so that cancels out to leave us with just 1G. $6.50 divided by $1.50 is 11. No answer to any word problem is complete without the units. Units is a word to describe what the number stands for.
How are we getting 11? Oh.
150 goes in one time, leaving me, or 150,
No.
150, one time. Decimal pop
Oh,
straight
yeah,
up.
because it doesn't make sense to have
So, the other great thing about word problems, especially word problems like these, is it gives us context. This is where your reading is going to come in handy for you. Some of your understanding. When I look at this, I want to think to myself, is this answer reasonable? Okay, Joshua was given $20. He's able to purchase 11 Gatorades. That makes sense. If we had gotten this, Joshua was given $20. He was able to purchase 110 Gatorades. Okay, that doesn't make sense. Joshua was given $20. He spent $3.50 on peanut butter and was only able to buy 1 Gatorade. Does that make sense? No. So this doesn't make a whole lot of sense if we have those answers wrong. Decimal places in the wrong place lead to answers that are wrong. The great thing about word problems is word problems, we have this context where we can use our brains and say, does this make sense? Is this answer reasonable? So that's the great thing about word problems. So there are really two things that we're really doing today. Number one, we're reading word problems, and we're reading questions from word problems, and realistically realizing that all we're really doing is solving equations. And then, because it's a word problem, we have this awesome tool to help kind of check our answer by saying, hey, Does this make sense? Is this answer reasonable? Okay? So, yes, Mr. Matlock.
I don't understand how we don't know if we have enough data because it doesn't say in here how many girls are on the volleyball team.
There are 12. All right. Ms. Crosby and Ms. Atkinson were driving home from LA. If they live 385 miles away from each other in opposite directions, and Ms. C drove 3.6 hours and Ms. A drove 4.1 hours, assuming they drove at the same rate throughout the trip, what was their speed S? So I hear somebody say, how do you do that? Well, I don't know. Let's just read the question. What was their speed S? So I know I'm looking for S. Good news, they gave me an equation with S in it. So all I have to do is solve for S. The rest of this doesn't really matter. Now, that being said, one of those things we can have in our brains right now, we can be thinking to ourselves, well, what kind of reasonable answer is here? So our two teachers are driving on the highway. We want to know what their average speed is. Their average speed. So when we're talking about speed in miles per hour, if they're traveling on the highway away from LA, what do we think a reasonable range of speeds would be? William?
65.
65, that's not a range, that's a number.
60 to 70.
60 to 70, that might make sense. Anybody want to expand that range a little bit, Mr. Ross? 70 to 90? I mean, I've seen cars pass me going 90 miles an hour on the highway. I mean, so I guess that's within the realm of possibility. But what if they hit traffic? Damien? 40 to 65? I think that makes sense. I think if they hit traffic, they may end up with an average of like 40. I think if they hit no traffic and, you know, they've really got their foot on the pedal and they're feeling particularly bold, they may go in as 90. So 40 to 90 seems to make sense here. So we want to solve the problem. We want to think to ourselves, you know, when we get our answer, is our answer reasonable? All right? So I have 3.6 plus 4.1 S. So I'm going to combine those like terms. It's going to give me 7.7 S is equal to 385.
I get it right.
And divide both sides by 7.7. So I've got over here 385 divided by 7.7. Decimal one time, decimal one time. 77 goes into 385. I'm going to estimate 70 is close to, or 77 is close to 70. 70 would go into 380 at least 5 times, so I'm going to use that as my starting point. 385, oops, sorry. 77 times 5. Let's see what that is. 5, carry the 3. Actually, that seems to come out perfectly for me. 385 goes in exactly 5 times. 385. 0. So my answer is S is equal to 5 miles per hour. Was this in our realm of reasonable decisions? No, because if they're on the highway, they're probably not going 5 miles an hour. And if they were going 385 miles at 5 miles per hour, it would have taken them like 40 hours to get home. So this answer doesn't make a whole lot of sense to us. So this is the point where we go back. Well, something's wrong. Sadie, what's wrong?
Decimal.
Yeah, our decimal's in the wrong place. We see that we should have filled in here. Our decimal should have popped straight up. 77 should go into 0 times. So our answer should be 50 miles per hour. Yes, sir.
You know how you said that it would take them like 40 hours?
Yes, sir.
They would 1 mile per hour. That's actually a lie because you could literally see that it will take them 77 hours because 385 goes 185.
All right. So looking at the next one. There's a typo in this problem. My apologies. I think this should say 250. Otherwise, the problem doesn't make sense. All right, Armani and Anthony wanted to save the money to buy a bike, which costs $250. Armani has $32 and saves $6 each week. Anthony has $65 and saves $3 each week. If they do not spend any money, how many weeks W would it take to save? So, again, I'm looking at this question. It says, how many weeks would it take to save $250? How many weeks? W. I need to find W. Good news. They gave me an equation. So all I have to do is solve the equation. The rest of this doesn't really matter to me. Now I can see where it came from. $32 is how much he already has. $6 times the number of weeks is how much he's going to get. $65 is how much he already has. $3 times the week. It's going to total up to $250. That makes sense? So let's go ahead and solve this equation. I'm going to start by commuting my like terms next to each other.
Shouldn't you have it in order? Or does it matter?
Doesn't really matter for solving it. So this is going to be 97 plus 9W is equal to 250. Add the negative 97 to both sides. 9W is equal to 143. Divide both sides by 9. W is equal to 143 divided by 9. Sorry, that should be 153. Sorry. 153 divided by 9 goes in one time. 9 would be 63. So I get W equals 17 what? Weeks. All right, does it make sense that if they're saving a total of $9 per week, it would take them 17 weeks to get $250? That seems to make some sense. I can get behind that. All right. Last one. Tina babysat her cousin over the weekend for the course of weeks. Blah, 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 blah. Blah, 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 blah. Use the equation below to find out how much Tina was paid per hour. H. Good news. They gave me an equation that has H in it. So all I have to do is solve the equation. 114.10 is equal to... Here I'm going to do some combining of like terms in my first step. It's going to give me 7.8H plus, I'll go ahead and combine these two terms, 5.85H plus 2.65H. I'm going to combine these two terms over here. 7.8H, 5.85 plus 2.65, 0, carry the 1, 9, 5, carry the 1. Okay, so $8.50 or 8.5H. And finally combine those last like terms. That's going to give me 7.8 plus 8.5 is 3, carry the 1, 16.3 H, 114.10. This is now an easy equation to solve. Divide both sides by 16.3. And so I've got this division over here, 114.1 divided by 16.3, decimal one time, decimal one time. I'm going to think about this as, I guess my best way to approximate this is like, I don't know, 100 or 200 and 1200, so that would go in 6 times, so I'm going to check that out.
I guess I'll go in 6 times because it's already bigger than the
163 times 6.
That's 18.
8 carry the 1 is 7, carry the 3 is 978. 978 isn't really that close to 1,141, so I'm going to try
7.
one more time. I'm going to go up. 4, carry the 1. Sorry, carry the 4. Actually, this one comes out perfectly to 7. So 7 what?
Hours.
It's not hours, it's how much they're paid per hour. So this is $7 per hour is equal to H.
Still had the last part right.
Now, do we have to ask ourselves, is this reasonable?
Yes.
Those of you who are in the babysitting trade, you would know, is this reasonable?
Yes.
Yes, this is reasonable. Getting paid $7 per hour. I know this is reasonable because I asked this question in the first class and somebody was like, I get paid $8 per hour. So this makes sense. It seems that Tina's just not as good as Marquita. That's why she gets paid a little bit less. All right, questions about this work? Let's hit some key points. Oscar, key point number 1. Yeah. Pay attention, go straight to the question. Well, don't go straight to the question. After reading the problem, go straight to the question. Here, you're going to make me rewrite this because now you got me all befuddled here. So, focus on the question. To decide what you're being asked. Seems like a no-brainer, but we don't all do that. Other key points. Genesis.
Try to see if your answer makes sense.
Yep, check your answer. To see if it's reasonable. Anything else anyone said? Cool.